Alright, we're going to do 922. This video has a lot of jumping around in it, so essentially I'm going to kind of write down a couple of the problems, go to the coordinate plane and solve them, and then jump back. Still going to jump around a lot, but want to limit it as much as I can. Just want to get that out there in case you are kind of skipping around in the video and wonder where everything disappeared to and where we're at. So what if the inequality is not linear? Graphing the linear and non-linear inequalities. In lesson 921, you discovered that the solutions of a linear inequality with two variables can be represented by a shaded region on one side of a line. But how can the graph of an inequality help solve an everyday problem? And what happens when the inequality is not linear? Consider these questions as you complete the following problems with your team. So 952. Review what you learned about graphing inequalities in lesson 921 by graphing the inequality below. So we're going to review graphing inequalities. Then we're going to answer these three questions. What's the minimum number of points you need in order to test which region has the solutions and should be shaded? Should we check point 00? Why is that a good idea or a bad idea? And should we check point -32? Is that a good idea or a bad idea? Again, I'm going to go over the coordinate plane. I have these questions sort of jotted down on the side, and I'm going to go through all three of them before I return to problem 953. So try this and see if it allows me to sort of do it this way. I don't know. So again, we're doing problem 952. The first thing it asked us to do was to graph this inequality. So I'm going to go to the y-intercept of -3. My slope is down 5 and over 3. But again, if I go down 5 and right 3, I can go up 5 and left 3. And sometimes I like to do that if I sort of run out of room. You can see it's a solid line. Let's see if how good of a line I can get there. Not terrible. All right, now kind of answering some questions. Which should we shade? The first question was, if you'll remember, how many points do we really need to check? And we really only need to check 1 point. I'll be honest with you, it might not be terrible, especially on a test or the SAT or something, to check one on each side just to kind of confirm and make sure you're right. But really, you only need to check 1 point. If it's true, you're going to shade that side. If it's false, you're going to shade the other side. B asks, is it a good idea to check point 00? Well, 00 is a good idea, I think. It's not on the boundary. Again, you never want to check something on the boundary, and I'll show you why in a minute. And 00 is very easy to sub in. If I sub in 0 for the y, and I sub in 0 for the x, we're going to get 0 is greater than or equal to 0 minus 3. So 0 is greater than or equal to minus 3. So if 0 is greater than -3, that means that we would shade that side. And 0 is indeed greater than -3, so we're going to shade the side with 0, 0 on it. Again, if you remember from 921, I believe it was, we talked about, you can also, if the variable's on the left side, just say, oh, look, we should be shading more than the line. Well, more than the line is this one, above the line, right? So that's where the y-axis is bigger. The next question is, should we check point -32? Well, normally checking -32 is probably not a big deal, but on this one, -32 happens to be a boundary. And we already know everything on the boundary is true, so there's really no reason to check it. But I do want to show you what happens if you check a boundary point. So if I sub in 2 for y and -3 for x, look what happens. You will notice a negative times a negative is positive. That turned into a 1, so I get 5 minus 3. So I get 2 is greater than or equal to 2. Well, I already know that 2 is equal to 2 because of that equal sign. So anything on this boundary is going to end up being where it's equal. Like here, it wasn't equal. This is going to be equal. So I would expect -1, -2, -3. If I check point 0, -3, you'll also see it's a bad point to check because it's also on the boundary. But specifically, I would expect them to be equal to each other. So again, let's sub that in. I sub in -3 for y. I sub in 0 for x. And I get -3 is greater than or equal to, again, that zeroes out, -3. So again, you can see the similarities of any time you pick a point on the boundary. If you pick that point, it would be equal. If you pick that point, it would be equal. And again, equal is true in this case. If it looked like this and it wasn't equal to, then equal would be false, and that's why we would have a dotted line. So I hope that makes a little bit of sense why we want to not checkpoints on the boundary, again, because that equal sign or not equal sign tells us if it is or isn't. All right, so let's go ahead and jump over to, let's see if this will allow me to do this. I'm not sure if it will. Oh wait, I think I did the wrong one, huh? I want 922A, I think. Okay, so we had already answered question 952A, B, and C. So now we're down to 953. So foreign aid, one of the purposes of the United Nations is to have nations work together to help each other. Recently, the members of the UN decided to give grants to poor countries to help reduce poverty. However, the United Nations only has the resources to help those countries with the greatest need. Therefore, it was decided that only countries in which the number of people in poverty is more than half of the population would receive foreign aid. So a constraint is a limitation or a restriction. If you study business like I did in college, you're going to come across a lot of constraints, and you do a lot of this kind of math. Maybe something like, you can only put so many pallets on a train cart is a construction, or you can only make so much orange juice in a day is a constraint or a restriction. So those constraints come up a lot in this kind of a math. Anyway, it says write an inequality that represents the constraints of receiving foreign aid. Let X represent the population, and Y is going to represent the number of people in poverty. So that's going to be important. It's going to ask us to open this resource page, which I'm going to do in a minute. We'll keep in mind the X and the Y, and we'll also keep in mind here what we're going to graph. We're only going to graph that the number of people in poverty is more than 1/2 of its total population. So the number of people in poverty is more than 1/2 of its total population, right? Number of people in poverty is more than half the people of the total population. It's not going to be equal to. It doesn't say it can be equal. It's got to be more than. So this is the inequality that I'm going to use over in this resource page. So we will jump over to this resource page. And answer that question. You can see it's same kind of question there. So we're going to say Y is greater than 1/2 X. If you remember, the number of people in poverty has to be more than half of the total population. So I'm going to go up 1/2, up 1/2. Normally I would skip to bigger, but I think Rwanda ends up being like right on the point, which is interesting to kind of discuss about this, because like I said, we're using not that one, not that one either. We are using a dotted line for this one, of course, because it doesn't say equal to. So the question is, which countries does it include? Well, looks like Honduras. Rwanda is like right on the point, so I would say no. It could be that if we zoomed in, we would see Rwanda is a little bit above the point or a little bit below the point, but just looking at it, it looks like it's right on the point, so we're going to say no, not Rwanda. Zambia, Madagascar, Uganda, it looks like Peru just misses out. Tanzania misses out. So these are the countries that are going to get aid. These are the ones that are not. I think I'm jumping back to A, but I could be wrong. So at this point, we had answered 952, 953. So let's jump over to B for problems 954, 955, 956. And actually, 957. All right, so 954, 55, A, B, and C, it's basically asking me to graph on the coordinate plane. So again, I'm going to jot these questions down, answer 54 and 55, A through C on a coordinate plane, and then I'll come back and we'll discuss 56 and 57. So anyway, what is an inequality in nonlinear? So we're going to graph this. Hopefully you recognize this as y equals a times b to the x. So we'll deal with that. Then here, again, we have a y equals a times b to the x. Well, when I say equals, it's the form of that. Clearly, it's an inequality, so we'll deal with that. And then we have two lines, but they're the x equal and the y equal, which makes it a little bit interesting. We may or may not remember that or what we want to do with that. So I missed. There we go. All right, so we will go here, and I will start with problem 54. So it's y is greater than 3 times 0.8 to the x. Interestingly enough, not that anybody cares, but at a little bit past this point, the first time I was filming this, I was interrupted and had to redo it, and this is now the third time I'm filming this because the second time got screwed up, so I really want to be done with this lesson. Anyways, my zero term is 3. I'm going to go back a little bit for -1 and -2, just talk about that in a minute, but hopefully we all remember this, that I just need to start multiplying by 0.8, right? So I'm going to multiply my output by 0.8. I already have these in the calculator because this is where I got stuck last time. This is exactly where I was right here when I got interrupted. Anyway, you can tell I'm not over it yet. So if I'm going to multiply by 0.8 in this direction, I'm going to divide by 0.8 in this direction. So 3 divided by 0.8 is going to be 3.75. And then 3.75 divided by 0.8 is going to be 4.68 or 4.7. And the reason I want to do that is I want to have a couple of points back here. If I just graph from here, it looks really, really, what am I doing? That's 2.4. It looks really sort of unfinished, I think. 1.92, we'll put about right there. 1.56. So you can see we're getting that asymptote. Actually, you might want to go a little bit more. So 1.536 times 0.8 is going to be 1.228. And then times 0.8, I'm going to get 0.98. So just going out a little bit more, you can see we're starting to get that flattening. But again, I wanted to go -1 with 3.75 and -2 with 4.68, just so you can sort of see what's going on here. If I went back one more, I would get 5.85. So I just want you to see a little bit of kind of what that curve is starting to look like there. Now the question is, which side should I graph? Well, if I use the shortcut, it says greater than. Here's the y, here's the x, so I think I should shade this side of it. And again, you know, I know I'm going to get some sort of like an asymptote over here, so I'll sort of finish that off in both directions. But I think with the greater than, I'm going to shade above. Well, an easy point to check would be 0, 0. And 0, 0 should be false if I sub this in. So I'm going to say 0 is greater than 3 times 0.8 to the 0. Now you're going to really see the benefit of 0. What is anything to the 0 power? Hopefully you remember that anything to the 0 power is 1. So is 0 bigger than 3? 0 is not bigger than 3, so I didn't shade it. I shaded the other side. So I hope that makes sense. Again, it's just like the line. All the rules are the same, but we have a curve instead of a line. So not a huge deal. That ended up, again, being a problem. Man, should I just... I think I'm just going to go to new coordinate plane, honestly. I think it'll be a lot faster. All right. So now, if we go to 955A, it's asking us to graph y is less than 4 times 1.15 to the x. Now on the last one, the multiplier was 0.8, so it was going to get smaller. This one, the multiplier is 1.15, so I know it's going to be bigger. Again, I'll go here. I'll start with the 0 here at 4. My mistake. And now what I want to do is I want to start multiplying by 1.15. So again, I'll go a couple numbers in each direction so I have an idea there. So 4 times 1.15 is going to be 4.6 times 1.15 is going to be 5.29 times 1.15 is going to be 7.93, and then I get 9.125. Going in this direction, I'll divide 4 by 1.15, 3.47. I'll divide that again, and I get 3.02. So -2 is around 3. -2 is like 3.5. 0 was 4. 1 was 4.6. 5 was 5.29. I'm sorry, 2 was 5.29. 3 was 7.93. Finally starting to curve a little bit right here, right? It wasn't not a very dramatic curve. 6, 7. That one feels out of place to me. What about my 2? Should my 2 be higher? 2.4. I don't know. It doesn't look kind of as curvy as I feel like it should, but that's what I came up with. Maybe made an error in here, mathematical error. You guys will catch for me. I don't know. Anyways, it looks like I want to shade less than. So again, y is smaller in this direction, but let's confirm that by plugging in 0, 0. 0 is less than 4 times 1.15 to the 0. Anything to the 0 power ends up equaling 1. So 0 is less than 4 is true, so I shaded that side. So that was 955A. Now let's go to 955B. 955B, they asked us to graph y is less than, greater than or equal to -3. Well, again, guys, if you think about this, what they're saying is that y is equal to -3. So here y is -3, here's y is -3, here y is -3. Again, I think I told you that my daughter's math teacher told her that if it's y equals, that means it goes through the y-axis. So either way you want to think about it is fine. Again, I prefer to think of it as like this is -5, -3, -4, -3, -3, -3, -2, -3. The y is always -3. Anyway, I'm going to have a solid line, obviously. And I'm comparing this to y. And the line needs to be bigger than -3. Well, that's up here. Well, let's say I want to check point 0, 0. You'll notice I can't plug this 0 in. There is no x to sub in, but there's a y for 0 right here. And 0 should be bigger than -3, and it is. So that's why it looks like that. That's 955B. And then finally, we will go to 955C, which is asking us to graph as x is less than 2. And again, here's where x is 2. This is 2, 0, 2, 1, 2, 2, 2, 3, 2, -1, 2, -2, 2, -3. So the x is always 2. Or again, it goes through the x-axis. Doesn't matter either way you want to think about it. Again, now we're grading this on the x-axis. We're saying that x, now we're grading it left and right, not up and down, because this isn't a y. On the x-axis, the numbers are smaller too, or in this direction. So I would expect 0, 0 to give me a false. Again, I can plug in this one for x, but there's nothing to plug in over here for y. So I'll take this one and go 0 is less than 2, which is true, and that's why I shaded that side. So that is 955C. We will now jump back over again to this page and finish off 956 and 957. So it says, write an inequality for the solution graph that right. Be prepared to explain how you decided your inequality. Well, first thing I'm going to do is I'm just going to write the, let's say y equals, it looks like my slope is down 1 and over 1, 2, 3. So, and it looks like my y-intercept is -1. Now I'm going to go through and sort of figure out my shading. Well, it looks like it's less than, its y is less than, and it looks like I'm not going to have a solid line, so it's not equal to, so I'm not going to put a solid line. So my suspicion is if I plug in 0, 0 over here, I'm just going to double check it, that it'll be false. Anything times 0 is 0. 0 is less than -1, that is false. I didn't shade that side, I shaded this side, so I feel pretty good about my inequality. I appear to have the correct y-intercept. I appear to have the correct slope. So I think that's pretty good. Last one, graph this inequality right here. I'm going to create a little bit of space here on 957. So I'll just write this out. X squared, let me get rid of this, it looks like a negative sign. X squared plus 3 is less than x squared minus y plus 4 plus x. A couple things I'm going to do here. One, I'll subtract x squared from both sides. 2, I'll add y over here to both sides. Lastly, I'll subtract 3 from both sides, and I'll see what's left. So I have a y here. These cancel, these cancel. I didn't divide by a negative or multiply by a negative, so the inequality stays the same. Those cancel, those cancel. 4 minus 3 is 1, and I have an x here. I'll kind of move the order so it's in that order. So And then it says graph the inequality. Well, I'm at 1. My slope, don't forget, this is like 1 over 1, so it's up 1 over 1. Alright, this is going to look something like this. I want to shade, looks like less than, so I'll shade below it. And again, if I plug in 0, 0, it looks like it's going to be true. So 0 is less than 0 plus 1. 0 is indeed less than 1. So I feel pretty good about that. Alright, third time's a charm. Finally got through this video. Have a good day.